Hey, what's up, guys? What's crack-a-lagging? Welcome, welcome, welcome. Your first lab, first organic lab. Are you guys excited? I'm so excited. um, it won't be like splash, like color change, explosion that you guys, some of you might be expecting. But hey, we're gonna do sophisticated chemistry. Okay, it's gonna be interesting. All right, that's what I can tell you. It's gonna be interesting. All right, lab one, acid-base extraction. You have done a little extraction before, so you get to like touch a separatory funnel, try to shake it, vent, right, and those stuff. Okay, today we're gonna use those skills, but in real lab. All right. I'm going to talk about the theory behind extraction, solubility, do's and don'ts. It's very important to keep you guys safe. All right. All right. Let's go along with me. Sit back and relax, and let's go. Before we get to the detail, got a question for you. What would the Terminator be called in his retirement? Anyone here knows? What would the Terminator be called in his retirement? An exterminator. Got a dialogue for you. Let's say, well, what is this guy talking about? Dude, I don't know why my wife is mad at me. What do you do? My wife told me to pick up 6 Sprites from the store. I thought we might need more, so I picked 7 up. That's why. Okay, all right, let's talk about the solubility and mixability. Okay, the first thing you need to know. For example, ethanol and water. Is ethanol soluble in water? Ethanol means 2 carbon with an alcohol. Is ethanol soluble in water? Well, ethanol is an alcohol in beer, in wine. Have you ever like open a bottle of wine, open a can of beer, you pour it out to a glass, and you say, "Hey, dude, there's 2 layers." Do not drink that. Do not drink that. Ethanol is soluble in water, and the reason why it's soluble is they form the same interaction. Like this sauce, like if you remember that, all right, can form hydrogen bond. There's an ethanol molecules right here and as water molecules. They can form hydrogen bond with water, right? So the OH bond, I think you guys know, is a polar bond. So partial positive on hydrogen. Water, pretty much the same thing, partial negative on oxygen. And you guys know, negative and positive, they stick together, all right? Now, those who alcohol, larger alcohol are not soluble well in water, and here's the reason. Take a look, for example, 1-decanol. Right? 1-decanol have, of course, the OH group, the hydroxyl group, which is hydrophilic group. Okay, this one, water love this group. They form the same type of interaction, but it also got a long hydrophobic group right here, our hydrophobic tail. Right, these water have a problem because they don't form the interaction. Water want to form hydrogen bond, but this hydrophobic group, the alkyl chain right here, want to form London forces. So it doesn't go together, and then we end up with 2 immiscible liquid. Okay, so the small molecule, small alcohol soluble, ethanol soluble, propanol soluble. Now if we have like 4 carbon chains, like less soluble, 5 carbon chain, even less soluble. We have 10 carbon chain in decanol, not soluble anymore. Okay, next question is hexane. Look like this, hexane, so 6 carbon alkene, soluble in water. You can tell like right away this is guy's non-polar and water is polar. It's not gonna work. Okay, so like dissolve like polar compound dissolve polar compound, non-polar compound dissolve non-polar compound, right? The interaction is not doesn't match. This guy wanted from London forces, water wanted from hydrogen bond. Nah, immiscible liquid. Sodium chloride soluble in water. Yeah, it's soluble in water. Of course, you got like table salt. You guys know that, right? And the interaction form like this. Take a look. Sodium is positive. Anything that can bind to positive it needs to have a charge of negative. Okay, it's negative. Oxygen is partial negative, and it stick like that. Right? This interaction we call an ion dipole because the ion right here. There's a dipole from OH group, so we call ion dipole interactions. Chloride ion, on the other hand, so chloride is negative. What can stick with a negative? Can it form interaction with a negative? Of course, positive, right? So water will use the hydrogen, which is partial positive, and then bind to chloride, right? So in real time, sodium chloride look like this is like sodium chloride will got taken away by water molecules one by one. Now you can see that this is chloride ion, that's sodium ion. Okay, the sodium ion got oxygen point toward it, but the chloride ion got hydrogen point toward it. Okay. All right. Just review real quick, right? Intermolecular interactions. So we have the strongest one, ion dipole interactions. We have hydrogen bonds, which is exactly dipole-dipole, but stronger for OH, NH, and FH, fluorine, hydrogen. Okay. We have dipole-dipole interaction for polar compound, and we have London dispersion forces, or we call London forces. All right. The polar compounds from the top three, and the non-polar compound from the bottom. All right. And yep, yeah. The top three right here, usually the soluble, anything that can form the top three interactions, they are likely to be soluble in water. Right down here, usually not soluble in water, like dissolved like. Okay. Now, if you have to predict, so we have not like a rule, but something that you can use as a reference. For example, sodium chloride can form ion dipole with water. This guy's soluble for sure. Organic ions that have, let's say, 7 to 8 carbons or less. This guy can form, the one that can form ion dipole, hydrogen bond, dipole-dipole, with about 8, 7 or less carbon. This guy are soluble in water. Okay. Small polar molecules that can form hydrogen bond, dipole-dipole. This guy can form this guy are soluble in water. Ethanol, acetonitrile, dimethylformamide. You will see some of this later, but I'm sure you know ethanol. Organic compounds are larger but can form a lot of hydrogen bond. Okay, we have glucose, caffeine. This guy are soluble in water. Okay, so again, do not memorize this. You don't have to, but use as a reference. So something that look like this, 7 to 8 carbon or less, with a hydrogen bond, they can soluble in water. These are not soluble in water. Take a look. Or usually you can see pretty much a carbon chain. This guy all carbon, non-polar, not soluble in water. Triethylamine. Also, it got nitrogen in the middle, but there are 6 carbon, and these are not soluble in water, so very hydrophobic. We have vitamin D2, retinol. This is vitamin A. Some of you guys might have heard the word fat soluble vitamin. This guy right here, not soluble in water. Too many carbon chains. Okay. All right. Common solvent and solubility. So we're gonna talk about this on the next video. So you guys need to be familiar with some solvent that we're gonna use in the lab. Okay.